We'll just go ahead and get started, and yeah, we'll let the session kind of take us where it may. So my name is Dave Anderson. I'm the director of the Bioinformatics major in the Bachelor of Health Sciences. So hopefully everyone's here for that session. So I do have a few slides I'm going to go through to kind of give you all a bit of an idea about what the Bachelor of Health Sciences is about, what the Bioinformatics major in particular is about. And then I am keen to make sure that I leave lots of time for questions from all of you, if you have any questions about the program. I believe we're scheduled to have sort of a half hour in this session. I'll try to break with a couple of minutes anyway left, as I know many of you are likely jumping from session to session. Okay, so with that, I think I will just go ahead and share my screen. Okay. Okay, great. Well, thank you all for coming, and thanks for being interested in this program. As I said, my name is Dave Anderson. So I'm the director of the Bioinformatics program here in the Bachelor of Health Sciences at University of Calgary. And the Bioinformatics program is part of the overall Bachelor of Health Sciences. So we are located in the O'Brien Center. This is a program that is situated at the Cummings School of Medicine. So we are on sort of the Foothills campus primarily. Although our students are, of course, otherwise integrated into main campus as well. So you do take a number of courses kind of going across both places. Want to acknowledge the generosity of the O'Brien family, who have supported this program for many years from its outset, and yeah, have really helped this program become, the reputable program that it is. Okay, so the Bachelor of Health Sciences program, if you haven't had a chance to visit the session that's on the program as a whole, I would encourage you all to do that. So our Associate Dean, Undergraduate Education and Director of the Bachelor of Health Sciences, Ebba Kurtz, is doing 30-minute sessions about the larger program as a whole. I believe there's one a little bit in the early afternoon today, if you're able to make it. And this is a program that unites a few different sort of groups, I guess, within the health sciences. So it is a sort of multidisciplinary kind of program. There are a number of courses that the students across the program take together. I'll talk about the different disciplines a bit more in just a moment. But yeah, it's really a program designed to show students how to engage in health research from a number of different perspectives. And there is actually, one of, I think, the great strengths of the program is the fact that it unites these groups from otherwise fairly disparate areas together in a number of different places. And there are a number of different opportunities to kind of get engaged with each other. So here, just to give you a bit of a idea of some of the things that go on. So as I mentioned, we're situated at the medical campus in the Cummings School of Medicine. However, the students coming through this program, in addition to being exposed to the health sciences more broadly and the rigors kind of in that field, they get a lot of opportunities to do actually primary research themselves. So here, we've got a photo of one of our undergraduates presenting some of his summer research. Students have a number of opportunities to present both within the classroom and without, and to do a lot of writing, as well. And then I also want to emphasize, the access to a lot of other sort of cutting edge machinery. So as becomes most important for this field, we also have access to a number of different sort of research computing facilities. So this is one of the server rooms that we use. Yeah, so all of these opportunities are open to the Bachelor of Health Sciences students as a whole. There are three majors in the Bachelor of Health Sciences. So we have the Biomedical Sciences major, where students are primarily engaged in sort of conventional lab work. If we think of the sort of classic image, I think of sort of biomedical science, lots of pipetting, lots of experiments sort of at the bench. We also have the Health and Society major, so looking at some of the social determinants of health. And then the session that we're focused on here, which is the Bioinformatics major. So bioinformatics being a field that sort of unites the computational sciences and really leverages them toward understanding important problems in health. So, in bioinformatics, what our students typically are doing is really working on computers. So sometimes we do have some students who, do sort of combined projects that involve some bench work or some community work, but largely were really people who work kind of in the computational space. So, operating high performance computing machinery. We're working really with sort of cutting edge technology, I guess, in the goal of understanding more about questions about health. And so that's really the way I kind of define this field. Bioinformatics is sometimes a tricky to define field, to be honest, but for me, I would argue that the thing that really makes it what it is this idea that we are using computational tools. So we learn sort of the most cutting edge kind of computer science. Students will learn to code. Students learn to use, again, high performance computing machinery far beyond the scope of, your conventional desktops or laptops and that sort of thing. But it's with a specific purpose. And that's, I guess, the thing that distinguishes the bioinformatics majors, the bioinformatics program, from, computer science or computer engineering programs, which is that we are particularly interested in using these tools in order to answer questions about biology and health. And that's kind of the key piece there. So you'll see there, when I talk through some of the courses in this program, there is a significant emphasis on computer science, statistics, and other sorts of aligned areas. But the big defining advantage you have as a bioinformatician is you also get this cross-training in the life sciences that allows you to kind of approach these problems that would otherwise be inaccessible to people, even if they have sort of the most high-end computational training. Oh, sorry, I'm just noticing some questions in the chat here. You know what, I rather than get totally thrown off, I'll glance at the chat in just a few minutes after I get through this, if that works. Okay, so in the Bachelor of Health Sciences in general, we have a real emphasis on what we call inquiry-based learning. So basically all of the students who come through the BHSC program take the same shared set of what we call the core inquiry courses. So if you see these specifically mentioned, these are the 203 and 205, 308, 408, and 508. These are sort of the series of courses that run you all the way from your very first semester out through your very last semester, if you sort of go through the program as it's articulated. The reason we do this, and I really view this again as one of the strongest things about this program, is our goal is to give all the students who come through this really solid grounding in how to do health research. So there may be a number of different perspectives, there may be a number of different kind of methodologies and approaches to doing health research, but there are these really important, I think, critical shared elements. How is it that you guide your inquiry? How do you formulate your hypothesis? How do you design your experiment and collect your data, collect your results in order to evaluate the questions that you are interested in answering? So this extends, as I said, right from the very beginning. So the very first semester, students take a course in health research literacy that starts this process off, really starts to get you familiar with how you engage with scientific literature, how you can access, cutting edge information, and how you can then start to take the next steps to build upon it. It eventually builds up to the honors research project. So this is MDSC 508, which is basically a capstone. And the expectation is all our students complete this capstone project under the supervision of a faculty member, usually here at U of C, although there are some ways you can sort of get across supervision from someone outside, but generally speaking within the University of Calgary. And these research projects are very, they're the real thing. You're really engaging in sort of contributing to the field. They're very frequently lead to publications, and they're embedded within an existing sort of research lab. The nature of that lab and the nature of the work, of course, depends on your interests. And so that's where you see a lot of variation, a lot of opportunity, I guess, for each of the students to really sort of personalize this experience and take it where they're most interested in going. In addition, you do have a number of, as you progress through the program, you get increasing degrees of specialization. So courses that become more and more sort of specific to your major and to your field. And those will give you an idea of sort of how you can engage in this world, how all the ways in which you can sort of approach questions, the kinds of tools you can use, and that sort of thing. So maybe I'll jump into that, which is my next slide here. So bioinformatics, as I sort of mentioned, is basically this field at the intersection of biology and computer science or statistics. So what that means in a practical sense is that bioinformaticians are really kind of united by the sorts of skills that they develop. So the ability to use high performance computing machinery, the ability to analyze, really massive volumes of data, to create new software, so to write computer code in order to accomplish specific tasks that you are interested in doing. And more we're seeing is becoming quite common in the field is to use tools like machine learning algorithms, among many others. But basically, again, sort of within this big data realm, bringing these computational and statistical tools to bear in order to help us understand more about life. So how does this translate in a practical sense? Well, if you look through the course requirements of the program, again, one of the things you'll note is that this is very much a cross-disciplinary space. So bioinformatics students take first-year biology, first-year chemistry. They also take first-year computer science, first-year math, and then their first-year core inquiry courses. And so there are a lot of sort of requirements, a lot of parts to this foundation. But ultimately, as you'll realize as you go through the program, there's a reason for this. You kind of need these different perspectives and these different skill sets in order to be most effective in this world. In addition to those sorts of required courses, we have this core stream of bioinformatics courses. So starting in first year, there is a first year course, MedSci 201, which runs as a sort of intensive block week course in the winter, just after the new year. Called Applied Tools in Bioinformatics. So this course is going to give you some experience working with an actual high performance computing cluster, so located in our research computing services in their data center over on main campus. You'll learn how to remote access those machines, how it is that you can essentially drive them and use them to do scales of analysis and scales of computation that are otherwise impossible. From there, in second year, you go into an Introduction to Bioinformatics course. So here you get more of a survey of the kinds of core bioinformatics tools that are already out there and that most bioinformaticians really use at some stage of their career or of their projects. In your third year, you'll take a couple of courses, one on computational bioinformatics. So here you'll get more into sort of the development and design of your own algorithms and your own tools. As well as research methods in molecular biology and bioinformatics. So this course you take alongside the biomedical sciences students. In your fourth year, you have a few options at this point. So you can take an advanced bioinformatics course that looks at some of how you can deploy some of the sort of cutting edge analytical tools in DNA sequence analysis, as well as a course on AI applications in health. So this is where you get a chance to deploy some of those kinds of machine learning tools and techniques that you've likely heard about as they're sort of disrupting so many areas in the world right now. So you have these sort of core courses. You also have this, general other set of required courses that kind of cross a few different departments. But really, really critical, I want to emphasize the importance of the thesis. So the Bachelor of Health Sciences as a program is one of not too many that actually require this honors thesis. So every student who comes through this program is expected to complete an honors thesis in their ultimate year. And in bioinformatics, this means that you have a huge range, frankly, of opportunities to contribute to the health sciences and to do, like I said, real sort of cutting edge research. So bioinformatics students in particular, I would say, very commonly end up with some strong publications emerging out of their fourth year work, which is an incredible advantage to have, frankly, as you go out into the world, regardless of what pathway you take, to be able to demonstrate that you sort of engaged in this level of research is a really, a huge privilege to be able to have. So to give you a few examples, the other sort of thing that I quite like about the field of bioinformatics is the range that you ultimately have available to you. So bioinformatics, as I said, is a field that's sort of defined by the tool use, by the approach that you use to answer questions in the health sciences. But what that means is that the types of projects and the types of research that you see bioinformaticians engaging in is about as broad as the health sciences themselves. So for instance, these are just a couple of selected examples. Here we have a project that looked at developing machine learning models that would provide predictions for women during their pregnancy to predict their likelihood of a spontaneous preterm birth. So, essentially leveraging kind of cutting edge machine learning tools in order to potentially provide predictions that could really help shape an outcome for people in a clinical setting. So if you know that, for instance, someone has a high likelihood of preterm labor, well, that may change some of the clinical recommendations that you make, right? Around what they're doing, what kinds of medications they should take, how you monitor sort of their progression. Another program looked specifically at strategies for de-escalating therapy for head and neck cancer by actually identifying novel biomarkers. So developed a tool that would take in data that had been generated in a number of different cancer labs in order to design sort of customized or personalized therapeutic regimes for people with head and neck cancer. And so here again, you see it's an incredibly different project, right? Going from pregnancy going into cancer therapy. But what unites it is really this computational approach, right? The fact that in each case, we're leveraging scales of data and computational tools in order to, understand something that we otherwise wouldn't be able to. And just to sort of give a full range of, the kinds of projects that I've seen our students engage in, we also had a really great project come out of a 508 thesis that's looked at creating an accurate genomic simulator in the game Minecraft. So created this one student used their thesis in order to create a mod for the game Minecraft that actually made sort of the breeding process of these worms that he had built into the game, made them genomically accurate. So he built scaffolded chromosomes, looked at how the process of recombination would drive the inheritance of different traits, and actually sort of designed it so there was a kind of a reward system within the game. And this particular student was really interested in going into education. And so, again, there's this incredible range of opportunities in bioinformatics that really just depends on what your interests are, what you really want to do with the degree and with your work. Okay, so you have your honors thesis. That's a phenomenal opportunity for research, but I want to emphasize that there are a number of other opportunities for research across the Bachelor of Health Sciences as well. So this is meant to be a very research intensive kind of program. Starting in bioinformatics, I'll really emphasize the value of research even just in your coursework. So starting right from MedSci 201 in your first year, as I mentioned, you will be using high performance computing machinery, remote accessed, driving using a Linux-based system that mirrors every aspect of the best high performance computing machinery that exists in the world. And you will start that in your first year, and you will have that opportunity in your courses throughout the program and during your thesis and during your research. So this is something that's provided to you by being part of this program in this community. And it may seem sort of dramatic to emphasize the coursework element, but I'll mention that we actually have had several bioinformatics students publish just projects from some of their courses. So I'm not talking about the honors thesis in this case. I'm actually talking about a project as part of their semester-long course. In particular, I'll highlight a couple of students who were taking that MedSci 301 in the spring of 2019 as the COVID pandemic, took over the world. And they actually used their project in that course to study aspects of the genomic evolution of the SARS coronavirus, the virus causing COVID. That has led to a publication, a peer-reviewed publication, just from sort of their regular coursework, let alone sort of their honors thesis. Additionally, in the Bachelor of Health Sciences, we have these independent study courses that allow you to essentially work with an individual faculty member, design a project or some, learning experience that you can basically customize to yourself, which is another really good opportunity to contribute to real research. The last one I really want to emphasize, because this is a phenomenal advantage that students in this program have, are the support for summer studentships. So every year we give out dozens of summer studentships. So these are essentially grants that will pay you for the summer to engage in research. And I'll tell you that our bioinformatics students tend to have a very high degree of success, both in obtaining these grants and then in translating that experience into, publishable, recognized work in their field. The summer studentships also are a great launch pad for an honors thesis, and oftentimes we see students kind of using these opportunities for that. Finally, I'll also mention, the Global Health Initiative. If you're interested in sort of global health projects, this is something that's worth looking up as well, and that we've also had a number of Bachelor of Health Sciences students engage in over the years. Okay, so what do our graduates tend to do? Well, as I mentioned, the field itself has a huge range of possible ways of engaging in health research. And perhaps not surprisingly, then, we do see a huge range of pathways that our students ultimately take. So certainly common is professional schools, whether it's med school, law school, things like veterinary medicine, common certainly to the bioinformatics graduates. Many of our students go on to graduate school, obtaining masters or PhDs, going on in research in sort of the academic sphere. We also, however, see quite a few of our graduates go straight into industry. So whether that's sort of the biotechnology industry, which is its own sort of very big growth area in Calgary and in Canada right now, or whether it's actually going into a sort of a pure software engineering position. So our students, while the bioinformatics program is not the same as the computer science program, they do nonetheless have a very easy opportunity to really build up their sort of computer science coding foundation. And it's actually quite common to have our bioinformatics students pursuing a computer science minor, as it's relatively easy for them to obtain just because of all the required courses that you're otherwise already taking. So we do see a number of students go straight into software engineering positions after graduation. We also see lots of folks engaging in sort of international work, going into health and public policy, health admin, project management, and then finally entrepreneurship, which is also a relatively common opportunity that we see our graduates heading out to. Okay, so I want to wrap up so that I can leave at least a few chances for some questions, but I'll also just mention there are a number of other sort of support components in the program. So whether it's the buddy program or the mentorship program, these each pair off first-year students with either a senior undergraduate student or with a faculty member, respectively, in order to provide some help and support. So we do really value the opportunity to build community around this program. And again, I would argue that one of the great strengths of it is actually this sort of the larger relationships that you'll get a chance to build with your colleagues, with your faculty, and that sort of thing. It's not a huge program, and so we really do have a chance to kind of get to know each other to a significant degree. We also hold an annual research symposium. So this is an opportunity for students to share the product of their research work, whether that's from courses, summer studentships, their honors thesis, or whatever. There's also the Health Sciences Students Association and the Student Faculty Liaison Committee. These are other sort of support structures, places you can go for help, for insight, for mentorship, for guidance, whatever it is you're looking for. So that's where I'll maybe stop here. I'll stop sharing the slides just for a moment, and we've got a few minutes left. I'll invite any questions if you have any. Feel free to either speak up or throw it in the chat, however you prefer. I'll keep my eye on the chat now that I'm out of my slides. Or perhaps I just made everything just abundantly clear. Can we go to this course straight from high school? Do you need to take other courses before this? No, you can direct enter from high school. That is what the majority of our students do. So you'll want to have a look at what the prerequisite requirements are, which are contained on the U of C website. If you look up Bachelor of Health Sciences Bioinformatics program, Bioinformatics major, sorry. They're listed there. You can also send an email to bhsc@ucalgary.ca for any questions like that. But yes, the majority of our students do come directly out of high school. Besides that, we do get a handful of transfers over from other programs, some from computer science, some from others. So really, yeah, it depends. But that's the most of the students. Interested in going into medicine? Yeah, so certainly, I mean, most medical schools just require any bachelor's program, right? So this is a bachelor's program, and so it would qualify certainly on that basis. This is also, of course, a Bachelor of Health Sciences. So, one might argue that there's a relevance there that's particular. So, the bioinformatics majors, I think, are generally pretty well received in the medical school admissions process, to be honest. I mean, I think it's a fairly well-known, rigorous program. And certainly this is a skill set that is being recognized as being more and more important in the clinical sphere. So yeah, I think it's not a bad pathway that certainly we've seen many students take. How hard is it to achieve a great GPA in bioinformatics? Well, I mean, it's certainly doable. I mean, we've had students come through with excellent GPAs. As with any, I think, program, certainly with the Bachelor of Health Sciences, I mean, it's a rigorous program, right? I mean, if you're looking to kind of float through, easy courses only, don't come here. That's not what this is. But yeah, I think if you work hard, I mean, certainly we see lots of our students come through with really excellent GPAs. I mean, I think, to be frank, we're pretty selective with who even gets into the program, and most of our students do exceptionally well. I'll also emphasize, though, GPA is not everything when it comes to the undergraduate experience, and that's a big part of why I spent so much time kind of emphasizing the research opportunities, because most professional schools, I think med schools included, would very much view accomplishments like, say, a published peer-reviewed research paper as being an incredibly good indicator of your strength as a potential professional or researcher going on beyond the undergraduate sphere. So yeah, so it's certainly doable. I mean, it's all about working hard, figuring out how you learn well, and really engaging in the work ahead of you. Oh, average GPA, sorry, I'm just seeing that. Okay, so I think Tharwat is sort of linking to, the requirements there. So the average GPA does vary. It's generally relatively high. I mean, I hesitate to even say a ballpark, because it does change year on year. And the reason that there's variation there is we do have a supplemental application as part of the process. And that supplemental application matters quite a bit, actually. We really do sort of strongly look at those other aspects of an applicant, how well-rounded they are, and that sort of thing. So again, I'd encourage you, if you have questions about the specific sort of admissions process, what the supplemental application is, when it's due, those sorts of things, you can always email bhsc@ucalgary.ca, and our program administrator will be, she's excellent in terms of having all those details to you quickly. Yeah, so generally at least at 85 or above, that's fair to say, yeah. Okay, I'm seeing that we are at 11:30. I don't want to hold anyone back, because I know that many of you are shifting from session to session. So we'll tie things up for now. Thank you all for attending. Hopefully this was some help in helping you make your decisions, and good luck to all of you as you're figuring out your next steps. It's an exciting